Hello, this is the end-to-end walkthrough on how to set up the food waste demo environment. The first thing that we have to do is, in an Azure subscription, create our key vault. Now, always best practice to create resources in a specific resource group. So you're going to create one for the Fabric demo, just to store one or more resources that we might need for this demo. Now, for this demo, we actually only need one single resource. But still, good manners and good practice to create a resource group first. Now in the Fabric Demo 1, we're going to now create the key vault, which we're going to use to store the API keys that we need to talk to OpenAI. You could, in theory, put the API keys directly into your notebooks, but this is a more secure way and also allowed us to share all the notebooks without sharing our keys. So we're going to create a new key vault for the Key Vault Fabric demo. And we're just going to keep all the default settings. Clicking next on all the default settings. Sometimes it's a good idea to add a tag, but for today we're just going to skip that and create a key vault in Azure. Now that doesn't really cost much money. We're talking cents. Now before we can create our API key entry, we first need to give us permission. So we're going to go into access control and add ourselves using role-based access. Now the permission we're looking for is actually not key, but secret administrator, or it's called the Key Vault Secrets Officer. With that role, we can create secrets, we can read them out again. The only thing we can't do is manage extra permissions. So once we've received the Key Vault Secret Officer permission, we can now create the secret. Now careful, it's not a key, it's a secret that we're storing that's got the API key in it. So we're going to create a new one and give it a name. Now the message might say it'll take some time for you to receive the permissions after you've given them to yourself. So if it doesn't work the first time, try it again. Second approach normally works. So this is the OpenAI key which we're pasting in. We are in our demo going to be doing two different challenges with OpenAI. The first one is estimating how long food's going to last and creating recipes. We're going to use the Azure OpenAI key we got from the hackathon for this. But a little bonus on top is actually to create a fine-tuned model, like a master chef, that suggests recipes that are a bit more special, and for that we needed OpenAI. Now, in the workspace, we're going to create a lakehouse. That's going to store two tables. The first table is going to be a fridge contents, and the other one is going to be a product database that we're going to download from Open Food Facts. So once we've created the lakehouse, we're now going to start by importing the different notebooks that you can get from the GitHub repo. So we got 4 notebooks that you can import. You can also import them all at once, by the way. The one to generate some sample data, one of them to download the food database, one of them to ask ChatGPT how long a product will last, and the last one to show you how to do fine tunings and create your own master chef. We'll also need an environment. The environment is a pre-configured list of Python DLLs that you want to use within your notebooks. The default OpenAI DLL is too old, outdated for us to actually work with it quite properly, so we need to get the latest version. And we create an environment for you. You can also use the one from the GitHub repo that includes OpenAI version 1.12. Got to save that and then got to publish it. There's not much that we're adding, just that one single DLL, but the downside is every time you're going to be using that environment, it's going to take roughly a minute to boot up your Spark pool. Now that's going to take some time in the background to actually install. So you're going to leave that running in the background. And while that's happening, we're now going to go ahead and start downloading our product database. Now careful, the default lakehouse will be connected to the wrong environment, so you have to remove it and add the lakehouse that you've just created. That'll now update the notebook using your default lakehouse, which you've just created. And that's then going to download the Open Food Fact database file, unzip it, and then create a products zip table in your lakehouse. And this also is going to take roughly 10 minutes to complete. So you can actually keep this Python notebook running in the background and carry on with your setup tasks. So the next thing we're going to do is we're going to add some dummy data to our lakehouse. So we created the generate data notebook. You can execute that, but remember, before you do that, change your default lakehouse, remove the existing one, add the new one that you just created, and then you can execute this one here. We can see it's already started importing the food fact zip file in the background, and we can now run this to generate some dummy data within our fridge. It also creates the fridge table for us, which we'll then need in the next step to start working with a semantic model. Then we can see it's now created the table. So a quick look at the table. We can use a SQL endpoint as well to get a bit more information from that. We can see the products are in there. And using the SQL endpoint, we can now start editing the default semantic model. So we're going to add the fridge contents to the default semantic model. And once that's been configured, we can start adding our measures to the model so we can start calculating when a product's going to expire and creating the trigger to react on an item that's about to go off. So we're going to create a new measure. And we've also created a DAX file for you guys to use in the Git repo to give you the syntax for the measures for the default semantic model. So the first one is expires in as many days. In this case, we're calculating 5 days for our rules engine, and the next one is a list of ingredients. So this just concatenates all the ingredients in the fridge together into one big list. We'll need that later for the email. So now we know when they expire. Now we know what they are. When we need to create the email, next step is to actually get the report up and running. Again, in the GitHub repo, you'll get the report, but it's going to connect to our environment. So it's going to give you a nice little error message, but it's easily fixed. Go into transform data, data source settings, and then pick your lakehouse as the data source. And then you'll just need to refresh the data, and you should see the dummy data appear in this report. And with that to go, you publish it to your workspace. So this will become the basis later for us to create a trigger on when the food starts going off in the fridge. You can quickly test it in the browser, make sure it's actually working by clicking on the link, and we can see that the chicken's going to be going off in 4 days. Now, one more thing we'll need to configure is the Python script that will add a new product to the fridge and ask OpenAI how long it's going to last. We'll need to first now change the environment. Well, first we'll change the lakehouse. Again, remove the broken connection, add your own lakehouse to the connection. And then we'll also have to fix the environment next. So we'll pick the OpenAI demo environment that we've just created in the previous step. Not quite finished yet. We're also looking up the API key in the key vault. So your key vault is going to have a different name to ours. So make sure you go back to your key vault and copy the URL for that key vault, get that into your clipboard, and then paste that into the notebook. Now, depending on what key name you gave it, you'll also have to then get the right key name. Now, make sure if you're just using the Azure Hackathon key, then just make sure you use the name for the one that you stored there. In our case, it's the AZ OpenAI key. And we're good to go. Let's give this a test and run through the notebook to see if it can actually make a prediction. We're just using some default values here. So we've got an unknown product with a certain barcode that we're going to be looking up in the Lakehouse food facts or food waste data Lakehouse. So if you've named your Lakehouse differently, you can also change that parameter name if you want. And it's going to look it up in the database, and then it's going to go to ChatGPT, 6 months, convert that to 180 days, save that to the database. It's a bag of almonds that we're storing, and that'll last until August, nearly September. So far, so good. Now, let's go to make.powerapps.com and upload the solution file that we prepared for you guys. So you'll find that under the Power App folder and import the solution file into your Power Apps environment. A word of warning, this solution does require some premium features, so you might have to activate a premium trial for this baby to work. Make sure you connect all of your different data sources, connect to Power Apps. The Key Vault name will be different, so you'll have to fix that up and give it the correct name based on yours. They're globally unique, so there can't be two Key Vaults with the same name. So make sure you put in your Key Vault name in here. And then sign in to authenticate against it. Remember, you need to have the secrets officer permission to be able to read out from there as well. And also the Entra ID HTTP request, that's the request we're going to do against Fabric, it needs to be configured, and it's the api.fabric.com URL that we have to put in both text boxes and authenticate against that to make sure that it uses our credential to connect to the workspace and execute the notebook. So that's all we need for the initial Power Apps, Power Automate flow to actually talk to the notebook and have the notebook ask GPT for how long a product's going to expire. Now, finally, it's finished installing. Let's have a quick look what's in here. We've got a couple of resources. We've got 2 flows and 1 Power App, and it's the send barcode flow that we're using to send whatever we scan in the Power App to the notebook. Now we have to configure that first because your workspace ID and your notebook ID is going to be different. So once you've imported the solution, 2 variables you'll have to configure so that that request can actually work. The first variable is the workspace ID. So get that from the browser. You can get that directly from your Power BI browser. And then the second one is the notebook ID. And that's the second part at the URL. Also, you can get that directly from the URL from the notebook itself that you want to execute. Let's give this a test. Always great to test your components individually to make sure that they actually work. We're going to just give it a dummy barcode, like 1, 2, 3, 4, 5, 6. And then we're going to give it a product. In this case, we're just going to try it out with frozen berries and see if GPT can tell us how long frozen berries is going to last. So this is now going to execute and send the request to the notebook. Now, guys, this request is going to fail. not because it failed, but because it's going to time out. Sadly enough, it happens asynchronously, and Power Automate hasn't quite figured out how to talk to a notebook properly. So the response code it's going to get is not what it expects, but it actually works quite nicely. If you go into the Python notebook, look at all runs, you'll see that there's now a scheduled job running, and that's what you're actually doing. You're creating a scheduled job, and that scheduled job is now completed. And we will now see, not straight away, but once we run a little select statement, we will now see frozen berries in the table, which have been added via the Power Automate flow. So far these components are working great. The next step is to get the Power App up and running. So we'll go back to our solution and we'll open up the Power App that's in the solution and just publish that so we can start using it on our mobile phone. So this is all working good. We press save and we press publish. Actually now doing both in one go. And that's going to allow us to then open up the Power App on the mobile phone, give it a whirl. Now I've prepared a little screen share for my mobile phone so you can see how it actually looks on the phone. So I'm just loading up Power Apps on my phone directly. I'm swiping up and choosing Power Apps in the search box. And then we can start scanning some products. That's the fridge inventory app that has been added. So the first test is, does the barcode reader work? So we can press the barcode reader at the top, and then we can scan a bag of almonds just to be on the safe side. Sometimes it might not find the barcode, so we're also going to scan a picture of the packet. So using AI Builder here to actually detect what's in the picture, a bag of nuts. And we're sending both of this to the Python notebook now. That should be running in the background and should be now looking for how long does it last. There we go. It's running in the background. And we should have a bag of nuts. Actually, no, almonds should now turn up in our fridge contents. Just going to do a select 100 to do a new fresh select statement. Sometimes the screen caching will tell you it's not there, but yeah, if we actually run it, there we go, Mandeln, barcode, expiry date, all there. So the Power App and the Power Automate flow work hand in hand. We're nearly finished. Last thing we need to do now is create a trigger that's going to allow us to trigger a recipe generator once the product expires. So we're going to say if the expiry date becomes less than 5 days, we're going to create a workspace. Then we're going to create a reflex on the in our demo workspace, and I'm telling it to not actually start the alert quite yet because we need to configure it first. Important now is once the trigger happens, we want to again talk to GPT and have it create a wonderful recipe based on what's in the fridge, based on what needs to be used. So it'll give us the chance to configure this activator, and we're going to create a new custom action, give it a nice name like create and send recipe. We're actually not going to pass any extra fields over to it. So we're just going to copy the connection string and say create a flow in Power Automate. But we're actually not going to use this template to create the flow because then we'd have to create it all manually and that would be quite painful. We have created something for you. So as part of the solution in the Power Automate and Power Apps environment, we've now got the get recipe OpenAI Power Automate flow, and we're going to use that instead. So the important part here is the connection string that we copied out earlier that changes for every time you create a custom action. So this is a new one. We're going to paste that in here. We're going to take the workspace ID. So again, that's the first ID from the URL. Going to put that in there. And the data set ID, we'll have to go to the workspace, go into the Lakehouse food waste semantic model, not the Lakehouse itself, but the semantic model, the default model. Copy that ID. That's the second part of the URL. And finally, just update your key vault. Make sure it uses the correct name that you've stored in your key vault, and press save. And we're actually good to go. Now, what happens here is if you've added the correct connection string and you save that, the background workflow hooks it up with your reflex. So it'll then go into a done mode, and you'll see the custom action available to you. And now we've hooked up that custom action to this reflex. And now the last thing we have to do is start the reflex. And we could actually also try to send a test alert. Now it takes roughly a day for the test alert to work, so it'll give you failed to create a test action right now. So give it some time, give it a day, or let it run on the background, and you will then get an email with some recipe suggestions based on what's in your fridge, nicely HTML encoded. So I hope you enjoy that. There's one last little bonus that we're adding on top of this game, which is a notebook that allows you to create your own little master chef. So again, make sure to hook up your lakehouse to the notebook. And we are now going to use OpenAI fine-tunings to use a fine-tuning file that's got lots of recipe ideas that go very strong into an Asian fusion vegan experience. So we're updating the API key again, the key vault. We're going to run through this. And this is now an example of how you can actually create fine tunings directly through the API and use them directly in your code. This is using the pip magic within the browser. So I'm using my default workspace and installing OpenAI directly in the session, which is a fair bit faster. I'm getting my API key from the key vault, and then we're now going to go ahead, get the training file from the GitHub repository, and start a fine tuning with that. So first we upload it, and then once we've uploaded it, we'll then start the fine tuning, and then we have to wait. Now this is going to take anywhere between 7 minutes and maybe even a couple of hours, depending if your job is being queued. In this case, it took roughly 7 minutes to finish the fine tuning on OpenAI with our Asian Fusion MasterChef recipe ideas. And now we can use it after it's run through and give it some ingredients like cucumber, capsicum, flour, and soy sauce. And it comes out with Mediterranean Asian Fusion cucumber capsicum fritters for you to enjoy with your recipe extravaganza. So this is it. This is end-to-end how to set up the food waste demo environment from Power Apps, Power Automate, use GPT to figure out how long something's going to last, use GPT to come up with recipe ideas, and even fine-tuning your own little master chef if there's a certain way you would like to have the recipes generated. I hope you enjoy.